All right, ladies and gentlemen, welcome to today's class. We are going to be talking about factoring using ax squared plus bx plus c method. Now, I'm not projecting your textbook like I normally do. I've decided to actually use the whiteboard because the method that I use is slightly different than the one that that is presented or projected to you in your textbook. What I am going to do is we're going to review real quick. So today we're talking about ax squared plus bx plus c. In the previous lesson, we talked about x squared plus bx plus c. And when we talked about x squared plus bx plus c, we saw that the leading coefficient of this trinomial was a 1. So when we worked with this method, the x squared plus bx plus c, and I gave you something like, let's see, I gave you something like x squared plus, there you go, that looks better, x squared plus 7x plus 12, and I wanted you to factor this, well, you would simply think of two numbers that when I multiplied equal 12, and that when I add them equal 3, and of course those numbers were 4 and 3, because again, in this case, 4 times 3 is 12, and 4 plus 3 is 7. So what we would do is simply factor it out, and we would say, well, this means that x plus 3 times x plus 4 is going to equal to x squared plus 7x plus 12. And of course, if you wanted to verify your answer, you would use the FOIL method, right? And it was pretty simple. Now, in what we're going to see today, we actually have this method right here. So let me go ahead and leave that there just for a second. And if you want, you can pause the video again. Just all I did was two numbers that when I multiply equal 12. And when I add them equals 7, that would be 4 times 3, which equals 12, and 4 plus 3, which equals 7. And then you factor them out, and you would write them as x plus 3 times x plus 4. So let me go ahead and give you guys a second to look at it, and now you can go ahead and pause the video or rewind it. And now, assuming that you guys have done, that you guys have paused the video and have verified what I did or rewinded it, let's get then into the topic that we're going to do today. We're going to look at example 1 and 2. These examples can actually be found on page 259 of your book. But right now, let's go ahead and do these two real quick. So what AX actually means, it means when the leading coefficient is not a 1. It's a number greater than 1, 2, 3, 4, 5, and whatnot. So what do we do when we have that? So if we look at example number 1 right here, I know right off the bat that, there's no numbers that I can think of that'll multiply when multiplied equals 6 and when I add them equals 17. And obviously, the leading coefficient here is a 5, so that means that I cannot use the method that I used prior, but rather I need to find something else to do. And the first step is to take the first coefficient, which in this case is the 5, and the last term, or which in this case is the 6, and you're going to multiply them. So 5 times 6 is going to equal to 30. Now, what does that have to do with the 17? Well, 5 times 6 equals 30. And now what I'm going to do with this 30 is look for factors of 30 that when I add them actually equal to negative 17, which is the middle term here. So I think of numbers that when I multiply equal 30. Well, right off the bat, I know 5 times 6, and I know 15 and 2. But the thing is that they have to equal to negative 17 when I add them. So 5 times 6 is out of the question. So that leaves me with 15 and 2. Now I know that 15 times 2 is positive 30, but I know that if I add 15 plus 2, I get 17, but I need them to be negative 17. So what I would do is I would just use negative 15 and negative 2. Because negative 15 times negative 2 is positive 30, and negative 15 plus negative 2 equals negative 17. So that means that this is the term that I am going to use. Now, what does that mean for my problem? That means that I'm going to rewrite my problem as 5x squared and then instead of writing minus 17x, I'm actually going to say minus 15x minus 2x because, again, minus 15 minus 2 is actually negative 17, or negative 15 plus negative 2 is negative 17. It's the same thing. And then finally, I have plus 6. So I'm not done with the problem yet because I still have to factor it. So now we're going to see something, or we're going to see a method called factoring by grouping. And basically, I just group all the 4 terms. I have 4 terms, right? The 4 this makes it like right, a polynomial, or 4-term polynomial. And we group them up. Now what we're going to do is we're going to factor them. So I'm going to think of, I'm going to look at the first parentheses, and then I'm going to look at the second parentheses. So I'm going to think of a number that divides by 5, that also divides by 15. And of course, that would be 5 itself. Now, notice that this is 5x squared and this is 15x. So the x is also a common factor here. So that means I'm going to write 5x. Now, what I'm going to do is I'm going to divide everything in the parentheses by 5x so that I can get the terms that I need to begin to factor them. Now, this is kind of like an imaginary division. You don't necessarily have to write it down this way. I like to do it because I like to kind of show you guys that the numbers aren't miraculously multiplying and showing up there, but that there is a reason for that. So obviously, 5 divided by 5 is 1, and I'm dividing by 5x. Excuse me, I forgot to write the x. So I'm dividing by 5x. Now, 5 divided by 5 is 1. And one thing that I know you guys saw in your Algebra 1, but we are going to review a little bit later on, is the exponent rules. And the exponent rule states that if the bases are the same, in the case of 5x, if the variable is the same, which is x, and if I were dividing these exponents, I would subtract. Technically, again, because they're both 5x, that means I can divide them. And there's an exponent of 2 here, because it is x squared, but even if there's no exponent here, necessarily a visible one, we assume that the exponent is 1. So basically, I divide 5 by 5, and then I subtract the exponents, 2 minus 1, which is 1, so that would be 1x or x, if you guys decide to write it like that, x. And then I'm going to do the same thing here. Well, 15 divided by 5 is 3, so I bring down the minus sign and the 3. And in this case, because both x's have the same exponent, which is 1, that means that they cancel out. And I'm done with the first part, but now I have to do the same thing here. So if I look at negative 2 and 6, I think of a number that divides by negative 2 that also divides by 6, and that number is actually negative 2. So that means that negative 2 is going to be the common factor. And why do I include the minus sign? Why? Technically, it's 2, but because one number is negative and the other number is positive, that's why I say negative 2. So let me go ahead and just write that down. Okay. And we will divide that by negative 2. In this case, notice that I do not include the x. And the reason I don't include the x is because in this parentheses, the only term that has an x is negative 2. So negative 2 divided by negative 2 is obviously 1. Or again, I can write 1x or x. It makes no difference. And then, of course, I have 6 divided by negative 2, and that would equal to minus 3. So notice that now my numbers are factored, and the common factor is x minus 3, which is what is inside of these parentheses. Okay, so again, the common factor is the x minus 3 because the x minus 3 is inside of the parentheses. So my last step is just to write the factored answer. And what I would do is I would take this 5x here and this minus 2 here, and I would write them together in the parentheses, and I would say 5x minus 2 and what I have left over, or what's in the parentheses, is the x minus 3, so I factor that out, and that would be x times x minus 3 here. And if you wanted to, and I'll do it in the second example, but if you wanted to, you could use the FOIL method to verify your answer and make sure that everything is in order and is correct. So that's how you do that one. Now let's go real quick to the second example right here, which is 3x squared plus 20x minus 7. And it is the same thing. There is no number that when you multiply equals negative 7 and when you add equals positive 20. So what we're going to do is we're going to multiply the first term, or the first term, yes, which is 3, which is the coefficient, times 7. So I'm going to multiply 3 times negative 7, which again, so again, the coefficient of the first variable, which is 3, times the negative 7. Okay, and then when I multiply that, I get that that equals negative 21. So now that I did that, I have to factor out negative 21. Now, I have to think of two numbers that when I multiply, or excuse me, I have to think of two factors of negative 21 that when I add them equals positive 7. So right off the bat, the only term that comes to mind is actually positive 20 times negative 1. And, or excuse me, not positive 20, I'm sorry. Positive 21, excuse me. Thinking about the answer. Positive 21. Let me write that better because that does not look like a 21. So I would say positive 21, much better, times negative 1. And negative 21 times negative 1 is obviously going to equal negative 21. But if I were to add 21 plus negative 1, that would equal 20. And that's what I want. That makes my answer correct. So what I would do in this case is rewrite the equation, but instead of saying 20x, I would say 3x squared. You know, and before I do that, let me just go ahead and erase this. So that way the numbers, so many numbers don't confuse you. Let me go ahead and erase this real quick. Let me go ahead and do that. That way we can have more space and maybe everything doesn't look so overwhelming. So let me go ahead and delete this. And delete this. Okay, so as I was saying, we multiplied 3 times negative 7, and that's where we got this negative 21. Now we factor out negative 21 into terms that when I add them equal positive 20, which is right here. And we found that the term that does that, or that best satisfies that, is 21 and negative 1. Because 21 times negative 1 is negative 21, which is here. And if I were to add positive 21 and negative 1, my answer would be 20. So that means I'm going to rewrite this expression as 3x squared plus 21x minus 1x minus 7. So now I factor everything by grouping, and that's just like what I did in the first example, which is I divide them by using two parentheses. And I'm going to do the same thing on this side real quick, right here. And I'm going to divide them right here. And what I'm going to do next is simply just factor them. So I'm going to think of two numbers that divide by 3, one number that divides by 3 that also divides by 21, and that number is actually 3, but not just 3, actually 3x. And the reason why I use 3x is because this term and this term both have the x variables, so 3x. The next thing is to do our division, or our imaginary division, and divide everything by 3x. And 3 divided by 3 is 1, so you can write 1x or 1. And then remember that because the basis is the same, and by the basis I'm referring to the variable, the x here and the x here, whenever I'm dividing exponents with the same base, I simply subtract the exponents. So 2 minus 1 is 1. So again, you can write 1x or x. It would be the same. And then you divide by 3x on this side as well. And 21 divided by 3 is 7. So that would be 7. So that would be positive 7x. And now we are going to do the same thing on this side. So the only possible common factor here is -1. It's the only number that divides by -7 that also divides by -1. That divides by 1, I'm sorry. And in this case, notice that I do not include the x, again, for the same reason, because x is only present in one of the terms. So my factor is -1, and now I simply just divide, and -1 divided by -1, well, that's positive x, or 1x, however you feel more fit to write it, and -7 divided by -1 is positive 7, and that would lead us with x plus 7. Now notice that everything in the parentheses is the same, so the next thing you guys are going to do is just factor everything out, and we're going to say, well, 3x minus 1, which is going to be in our parentheses, 3x minus 1, and what's in my parentheses, which is what I factored out, which is x plus 7. And I just realized that I wrote an x where it wasn't supposed to be, so let me go ahead and erase that. Let me just erase this real quick. It's not supposed to be there. There you go. Notice that everything inside the parentheses is the same. 3x minus 1, x plus 7. Now, I'm going to show you how to check your answer. And this is just using the FOIL method. So let's say I'm done with the problem, and I want to verify that this is correct. What I do is I simply use the FOIL method and I multiply. Well, 3 times x is 3x. And 3x times 7 is actually 21x. So 21x. And then I multiply, right? I continue using my FOIL method. It's actually 3x squared, because 3x times x is 3x squared, plus 3x times 7, which is 21x, excuse me. And then I multiply -1 times x, which is going to be -1x. And then you multiply -7, or -1, excuse me, times 7, and that would equal -7. And then 3x squared, there's really nothing I can do with it, so I pass it on to my final answer. And 21x minus 1x is actually 20x, so 3x squared plus 20x because it's positive. And minus 7. And notice how I got my original problem, which is right here, 3x squared plus 20x minus 7. So that means that this exercise is correct and everything factored out accordingly. So ladies and gentlemen, hopefully this video lesson has been helpful to you guys. So stay safe and we will see each other soon. Bye.